Hey, everybody. So we are getting into chapter 13 today. This entire chapter deals with what are called trigonometric ratios, or trig ratios for short. And as we go through this chapter, we'll be looking at three different trig ratios. The first being what's called tangent, and then sine, and then cosine. All right. The purpose of these trig ratios is to find missing side lengths and angles of right triangles. All right, and just so you know, a reminder, a right triangle is a triangle that has that right 90-degree angle. Okay, we've found the missing side lengths and angles of right triangles in the past, if you guys remember. The thing about these trig ratios is that we need even less information to be able to find these missing sides and angles. Okay, so that's really what's kind of neat about these is we don't even need two sides of a triangle to find another missing side. We can have even less information. Okay, so that is the purpose of this chapter. Today we're going to be focusing on the trig ratio called tangent. Okay, so let's get into it. Okay, so here it is, 13.1 tangent ratio. Okay, go ahead and take a couple minutes, get the title here, and get this entire slide because the whole thing is important, and then I'll explain what's going on. Okay, so first things first is it's going to explain, what a trigonometric ratio or a trig ratio is. So here's what it says. A trig ratio is a ratio of the lengths of two sides of a right triangle. Okay, so these ratios, they're just of two sides of a triangle. Okay, you will use trigonometric ratios to find the measure of a side or an acute angle in a right triangle. Okay, so we can do missing sides or missing angles. Today, we're just going to be focusing on finding missing sides, and then eventually we're going to get into angles after we look through all three of these trig ratios. Okay, so here is what the tangent ratio looks like. Okay, the tangent ratio is opposite leg over adjacent leg. Okay, let me just point out a few things here. First things first, we shortened, tangent into just tan. Okay, this A represents the angle we're going to be looking at. Here's the thing. Whenever we look at an angle on our right triangle, it's always going to only be one of these acute angles, one of these angles that are, smaller angles. Okay, so, in this context, we would either use angle A, or we could also do tangent of angle B. Okay, so that's all that letter represents is what angle are we looking at? Okay, but the big thing is this, opposite leg over adjacent leg. Okay, taking a look at the right triangle over here, just a little reminder, the legs of a right triangle are the two shorter side lengths. The hypotenuse is that side length opposite the right angle. Okay, so yeah, when we're talking about legs, we're talking about these two. Here's the big question and what we're going to figure out today. Which one is considered the opposite leg and which one is considered the adjacent leg? Okay, well, here's an answer to that. It depends on what angle we're looking at. Okay, so just a real quick summary. Say we were looking at angle A. Say that's the angle we were dealing with. Okay, well, the leg opposite this angle would be this one over here, literally opposite the triangle. Okay, so if we're dealing with angle A, the leg opposite is this one. So this is our opposite side. Okay, the adjacent side would be the other leg. Okay, technically the adjacent side length, adjacent means to be, like touching something. It's the leg that is touching the angle. Okay, but that's not the hypotenuse. Okay, so the one thing I also want to point out, when we make our ratios today, we're not using the hypotenuse whatsoever. Okay, when we get into the other trig ratios, when we get into sine and when we get into cosine, we will use the hypotenuse. But today, it's all about the two legs. Okay, so, let me just go back. What if instead of looking at angle A, what if we were looking at angle B? Okay, which leg would be considered opposite? Well, this leg would now be considered the opposite leg. And that means this leg would be the adjacent. Okay, so that's the first thing to wrap your head around. Opposite and adjacent all depends on what angle we are looking at. Okay, we can't just memorize, oh, this one's always the opposite leg and this one's always the adjacent. No, because it depends on what angle we are using. Okay, that's the big thing. So let's go ahead and practice finding these two side lengths, and then we'll get into eventually finding missing the missing side lengths. Okay, so go ahead and get this example here. We're going to find tangent of angle S and tangent of angle R. So go ahead and copy this whole thing. Okay, so first thing they want us to do is tangent of angle S. So let's just go ahead and start writing this out. So tangent of angle S equals, and we want to figure out what is the opposite side and what is the adjacent side. Okay, well, here's the big thing. If we're dealing with angle S, this is where our focus is. Okay, and it's not a bad idea to maybe highlight it if you were doing this problem on your own. Okay, so again, tangent is opposite over adjacent. Okay, well, what is the side length opposite this angle? Remember, it's literally opposite across the triangle. This would be considered our opposite side, our opposite leg. Okay, so 80 goes up on top. Okay, the leg that's adjacent to our angle, well, technically there's two sides that are touching this angle. But remember, this is the hypotenuse, and the hypotenuse is always just the hypotenuse. Okay, so that tells me that this leg right here would be considered the adjacent leg or the adjacent side. Okay, just one thing I want to point out. I think finding the adjacent side length is maybe the trickiest of the three things. I think it's pretty easy to find the side length opposite the angle. It's pretty easy to identify the hypotenuse, which remember is always across from the 90-degree angle. Okay, and that means the one left over is the adjacent. Okay, if that helps you figure out the adjacent side, that's the way to look at it. And then again, another way of looking at it is it's always the one of the legs that is touching your angle. Okay, cool. So there is a tangent of angle S. Some problems might actually ask you to divide these numbers and get a decimal. Okay, but for now, for us, we're good with just the ratio. That's all I want us to practice. Okay, we don't really need a decimal. Really, the decimal doesn't help us all too much, but you'll see in the future. Okay, so let's do the same thing with angle R. So tangent of angle R equals, okay, so now we're looking at this angle. And the first thing we're wondering is what is the side or the leg opposite this angle? Well, if we were to draw a line all the way across, this would be our opposite side. So it looks like 18 is going up on top over the side length adjacent to our angle. Okay, remember 82 is the hypotenuse. It's never going to be the adjacent, but that means this one here would be the adjacent side length, the adjacent leg. Okay, and there it is. That's the big thing. Is just being able to identify. Okay, this is the side length opposite the angle. This is the side length adjacent to the angle. That's really the big thing we're focusing on right now. Okay, cool. So I think I'm gonna have you guys go ahead and try one out on your own. Go ahead and find tangent of angle J and of angle K. And yeah, go ahead and try it out. Okay, so let's see how you did. So first thing, let's start with tangent of angle J equals, all right, let me lower this, is bothering me. All right, so tangent of angle J equals, okay, well, first of all, here is angle J. And just a little reminder, tangent is opposite over adjacent. So first thing, what is the side length opposite this angle? Well, it looks like it's 24. Okay, next thing, what is the leg adjacent to the angle? Well, just a reminder, 40 is the hypotenuse, the longest side. So that means this one would be our adjacent one. Okay, 32. Okay, and for now, that's it. That's all I want you to do. All right, let's do it with angle K. So tangent of angle K equals, okay, opposite over adjacent. The side length opposite angle K is 32. Okay, and the leg adjacent to our angle, the leg touching it, is 24. Okay, something you might notice, these are flip-flop from one another. Not a bad thing to maybe recognize, but I would not, try to make a rule or a shortcut out of that, because when we get into the other, tangent or trig ratios, you're just going to need to memorize the ratio itself, opposite over adjacent, opposite over adjacent. That's the big thing. Okay, cool. So there it is. So from here, we're going to use this information to actually find missing sides of a triangle. Okay, so for our next example, we're going to find X, this missing side. Go ahead and copy this. Okay, so this is really what it's all about. So here is the idea. when we go to find a missing side length, we want to use an angle that we know. Okay, right now they're giving us, and by the way, by an angle, I mean one of these two acute small angles. Okay, we know this one. Okay, so this is what we're going to use. Okay, 27 degrees. All right. And then, here's just the first thing I want you to start to think about. I have the side length opposite my angle and the side length adjacent to my angle. Okay, opposite over adjacent, that tells me we're using tangent. Okay, eventually you're going to have to be able to identify that. This whole lesson's about tangent, so you probably assumed that we are going to use a tangent. Eventually, we won't be able to assume. We'll have to be able to pick out, which one can we use with the information we have. Okay, so, let's go ahead and write it out. So we know we're using tangent of our angle, which is 27 degrees. Okay, and that equals opposite over adjacent. The side length opposite our angle is x. That goes up top. And the side length, or the leg adjacent to our angle is 15. Okay, so there's our equation. It looks a little crazy, okay, but this is something we can solve. Okay, here's how we do it. Okay, x is being divided by a number. This is just like any other algebra problem. If we have a number, if we're trying to isolate x, we need to do the opposite operation, right? So if x is being divided by 15 to get rid of it, we need to do the opposite operation. We need to multiply by 15, and we need to do that to both sides. Okay, so it looks crazy, but really we just, we solve for x here. So those 15s are gone. I like to start over here where my variable is and show, okay, we have x by itself. Okay, over on the left, this is what we need to type into our calculator. All right, this is the first big lesson. I've been like kind of preparing you guys this entire semester, telling you go out and get a calculator. You're going to need it. Well, this is the lesson. This is why you need a scientific calculator, because you need to be able to type this into a calculator. And if you just have a normal little one, you might not have these buttons. Okay, but if you want to check your phone, if you want to look at your phone calculator and kind of, you might need to look, deeper into the settings. As long as you see a tangent button, and then you'll also see a sine and a cosine button next to it, it'll probably be in this order on your calculator. You're good to go. Okay, if you don't have that in your phone, or if you don't have a physical calculator, here is the website I recommend using. Okay, it's called GeoGebra. All right, if you go to like Google and just search GeoGebra scientific calculator, it'll take you to this. And this is the one I like the most because it has the sine, cosine, and tangent buttons right there. All right, so this makes it kind of nice. And this is what I'm going to use just so you guys can actually see me inputting these values. Okay, so this is all we need to do is type this into our calculator. Sorry, there's a bunch here. Let me erase all this stuff. Okay, so this is what we're typing into our calculator, and I need you to do this with me because this is extremely important. So 15 times tangent 27. Here's the thing. We don't need to necessarily put the parentheses around 15, though it kind of depends on the calculator you have. Okay, so on mine, if you're using GeoGebra, we don't need to put parentheses. We can just say, okay, 15, and then we do times, and then what we're writing in, just to remind you, tangent 27. So tangent 27, there it is. And if you guys notice, there's our answer, 7.642. It goes on for a long time. Okay, and on these problems, just like normal, we're going to round to one decimal place. So the question is does that 6 stay a 6 or does it round up to a 7? And remember, it's all dependent on this number next to it. If that was a 5 or more, we would round up, but it's not. So this thing's going to stay a 7.6. Right? And that's literally it. And that took me a long time. By the way, I like to flip flop and write it as x equals 7.6 when I'm done. Okay, that took me a long time to explain. But if you guys notice, stepwise, this took us 2 steps. Maybe even just a single step to get our answer. All right. So this stuff really isn't crazy. It's just you need to know how to use your calculator. Okay. So if you haven't yet, type this into your calculator and make sure it gives you a 7.6. All right. So give that a try. And if you have questions, talk to me. Come back on the Google Meet or whatever and ask me questions, okay? Okay, so let's try another one here where it's asking us to, again, find a missing side length, find x. Go ahead and copy this. Okay, so same type of problem. Let me just kind of break it down. Here's the angle that we are given. So that's what we're going to use. Okay, and just to kind of start to get you to, kind of understand how we identify which trig ratio we're using, notice we have the side length opposite our angle, and we have the leg adjacent. Okay, opposite and adjacent tells us we're using tangent. All right, so we're going to go ahead and say, all right, we're using tangent of our angle, 32 degrees, equals opposite over adjacent. Be careful. What is the side length opposite our angle? It is 11. That goes up on top. What is the leg that's adjacent to our angle? The leg touching our angle is x. Okay, so here's the first thing I want you to notice. On this problem, our variable is ending up in the denominator. On the last problem, it ended up in the numerator. Okay, here's the good news. No matter where your variable ends up, you will always start your problem the same way, and that's multiplying by whatever is in the denominator. Okay, on this one, we had a 15 on the bottom, so we multiply by a 15. On this one, we have an x on the bottom, so we're going to multiply by an x. Okay, so multiply by whatever is in the denominator, the bottom of your fraction. Okay, and whatever we do to one side, we have to do to the other. Okay, so this is a little different. This is kind of strange. Let's break down what's happening here. These x's are canceling on the right, and we're getting 11 by itself. Over on the left, we have x times tangent 32. For now, we're just going to bring that down here. And the way I like to write it, instead of using parentheses, I'm just going to use a multiplication dot. So x times tangent 32 degrees. Okay, so first thing, notice we have not solved for x, not yet. We have one more step. Okay, we need to get rid of tangent 32. Okay, here's the thing to know. Tangent 32 is just a number. Okay, it's a number that's being multiplied by x. Okay, so to get rid of anything that's ever being multiplied, we know we need to do the opposite, and we need to divide. Okay, so we're going to divide both sides by a tangent 32 degrees. Okay, did it to the left, so we have to do it to the right. Okay, now these cancel and we get x by itself. Over on the right, this is what we need to type into our calculator. 11 divided by tangent 32. All right, and this is where we have to be a little careful. We'll see what happens when I type it into GeoGebra. Yeah, let's go ahead and do this. 11 divided by tangent 32. So going back to our calculator. By the way, if you're using this one, if you go to this here, you can delete. Okay, so delete it, and I'm doing 11 divided by tangent 32. Okay, and on this problem, I'm getting a 17.60, so that tells me this stays a 17.6. All right, so going back, I'm getting 17.6. Okay, here's the big thing. On your calculator, make sure you type this in and make sure you're also getting a 17.6. If you're not getting this answer in yours, you might need to type it in slightly differently. All right. So that really just depends. It always depends on your calculator. This GeoGebra, it did it for me perfectly without me having to really fuss with anything. So that's why this thing's kind of nice. Okay. But if you have your own personal calculator, you might need to learn how to use it. Okay. So again, if you're not getting a 17.6, come talk to me and I can help you out. Okay. Okay, cool. So yeah, that's finding that missing side. Here's another big thing I kind of didn't mention on the last one. Always check to see if your answer makes sense. If this short leg here is 11, does it make sense that the longer leg is 17.6? Yeah, that makes sense. That's not too crazy of a number, right? If we got like a 176, yeah, that would be way too big if this was 11. Same thing on the last problem. This side length was 15. This is the long leg. Does it make sense for the short leg to be 7.6? Yeah, this looks about half the length of this one. Okay, so it's always good to just look at your answer in the context of your triangle, see if it makes sense. All right, guys, so I'm going to go ahead and have you try a couple of these on your own. Okay, find the missing side length. Okay, round your answers to the nearest tenth. Do these exactly like we did on ours. Just be careful when you go to do these. Your variable is going to end up in different spots in both of your equations. Okay, make sure you're getting everything in the correct spots. Okay, so go ahead and try these out. Okay, so first things first, getting our equation written out correctly. On number one, we're using this angle that they provided. All right, we have the opposite side, we have the adjacent leg, so we know we're using tangent. This whole lesson is using tangent, but I just want to show you why. It's because we have opposites and we have adjacent. Okay, so tangent of our angle equals the side length opposite, which is 22, over the leg adjacent, x. Okay, on this problem, look at your equation. Make sure your variable ends up on the bottom. If you had x over 22, you're getting the two things mixed up. Okay, but yeah, from here, remember, always the same step. Whatever's in the denominator is what I'm multiplying by. So I'm going to multiply both sides, by x. Okay, on the right, those are gone. I have a 22. On the left, I'm just going to bring this down. X times tangent 61 degrees. Okay, and now finally I can solve for x by getting rid of tangent 61. It's being multiplied, so I'm going to divide. Okay, and we have to do to both sides. Okay, so they're canceled, got x on the left. On the right, this is what we need to type into our calculator. And again, that's one of the most important things, is knowing how to use your calculator. So everybody, again, try it out. 22 divided by tangent 61. So I'm going to clear mine. 22 divided by tangent 61. Okay, and I'm getting 12.19. Okay, so that 9 tells me this 1 is rounding up to a 2. So this is going to be rounded to 12.2. Okay, if you're not getting a 12.2 on this, come ask me some questions. All right, and just by the way, let's see, does that make sense? This long leg is 22. Does it make sense for the short leg to be 12.2? Yeah, it does. Okay, moving on to number 2, same idea. We are using this angle they're providing us. We have the side length opposite. We have the leg adjacent. So we know we're using tangent. So tangent 56 degrees equals the side length opposite, which is x, over the leg adjacent, 13. All right, so on this problem here, looks like our variable is ending up in the numerator, the top, which no matter what, doesn't matter. We're going to multiply by what's in the denominator. Okay, so multiplying by 13, both sides. And by the way, these problems where the variable ends up in the numerator are the easier, the quicker of the two. Okay, because all we got to do is multiply by that denominator. These cancel, and I'm getting, oops, sorry, what is going on here? Let me erase. Okay, we're getting x on the right, and on the left, this is all we need to type in our calculator, 13 times tangent 56. Okay, so let's go ahead and do it. By the way, if I wanted to use parentheses, I could, just for example, I could do 13 and then tangent 56. I would still get my answer, though, this is the same thing as if I were to write 13 times tangent 56. I'm getting the same answer. Okay. On these, because it works without the parentheses, we're good. We don't need them. Okay, but we might eventually in the future, just by the way. So 19.27, that 7 rounds the 2 up to a 3, right? So we'll write this thing as 19.3. Okay, and on these, go one more step. Put the variable on the left and the answer on the right. All right, and then last things, let's just check. Does it make sense for the long leg to be 19.3 if the short leg is 13? Yes, that answer makes a lot of sense. All right, cool, guys. So that is using our first type of trig ratio, tangent. We're eventually going to get into using sine and cosine, but if this started to make some sense, the rest of it's going to, be pretty simple. Okay, if you're feeling iffy on this, you're also okay. This is tricky stuff. Stick with me if you're having trouble on this. Don't give up, and then you'll eventually get it, I promise. Okay, I'll see you guys.